Hello there, this is Sohail Hasni, your host at Energypreneurs. Cheap solar power, batteries, and electric vehicles are changing the transport and energy sector as we know. I bring in guests to this podcast who will help you with their ideas to navigate this energy transition. Thank you for joining. Casper, good evening from Manila. Where are you today?
Good morning from Miami. I'm on the other side of the world.
Yeah, literally on the other side of the world. Do you maybe introduce yourself first? I read so many things about your company, doing a lot of exciting stuff.
Yeah, of course. Yeah, I'm Casper. I'm the CEO of Monta. Originally, I'm an electronical engineer, which went into software and then built tons of mobile apps for a decade. And then in 2020, decided to start Monta. So I'm a guy who would like to build stuff, and the more complicated it is, the more excited I get. This time went in on the EV charging industry and trying to kind of get that to a level where normal day-to-day EV drivers can figure out how to charge their cars without being an engineer themselves.
No, but is it really that complicated? Most of the people charging at home, and then those people who can't, they will charge at work or fast chargers. So what is the innovation space? You must be doing a lot of interesting stuff than what we see from outside looking in, no?
Yeah, I think at first glance, this industry looks super simple, right? It's just the outlet. But as soon as you start digging in a little bit, you unfold the layers of the onion, things starts being more and more ugly. It's an industry where you are kind of between the energy sector and the car OEMs. We work on a couple of different sides of the problem, right? One is the user experience, making sure that it's just as simple as possible for the EV drivers. It's a very big thing. And to really make it simple as possible, it needs to be very reliable. And that's why it gets complicated, right? The technology stack, where there's so many different stakeholders, which are all part of the transactions, and a lot of errors are just happening there. Tons of different hardware out there. And then it's the whole educating the EV drivers on that they used to be fueling their car with gasoline, which have been fairly straightforward the last many decades. And EV charging is not as simple as that, right? That it depends a lot on what is the state of your battery, what is the temperature, what is available at the site, is the cars parked next to you where you're sharing the energy. All that really impacts the charging curve, which means for the EV driver, how long time are they going to sit and wait for their car to be charged? So it is actually pretty complicated in that sense. You don't need a PhD in how batteries are working to understand how to charge your cars. But today, a lot of that is required. If you're driving an EV, a 20% battery and decide to charge, pre-warming the battery to get the optimal charging curve. That's a big thing, because if you come in with a cold battery at 12% battery, you will charge very slow. But if you come in with a warm battery, it might be okay. But if you are above 20% or 25%, it will even be a lot quicker. That's like the everyday driver sits with, and they shouldn't. That just needs to be fully automated and figured out for them.
Okay, let me understand as an EV user, because sometime if I say I want to go to a fast charger, then of course the car says that I'm warming the battery to optimize. So you are saying if I turn up to a high voltage DC charger with a car without giving any warning, then the battery is cold. The maximum capacity that I could charge the car at dramatically falls, right?
Yes, it will be very different. So let's take a fairly modern EV charge peak between 150 and 250 kilowatt. If you come in at 10% battery with a cold, you will not see for 50 kilowatts. It's that big difference, right? Okay. So that means you will end up spending 45 minutes at the charging site instead of 20 minutes.
Okay, that's a good information. Then if you are in the ecosystem of Tesla, then of course the car talks to the charger. But if you're outside the ecosystem, then are there common platforms that you use? How do you tell that?
So Tesla, they made that functional 5-6 years back, that if you picked one of the superchargers on the routing, it would know now on pre-warming. I noticed there's nowhere where you can go in and setting somewhere and activate it. So if you picked a non-Tesla charger, it was not aware that now it had to pre-warm. That came in now, but it's fairly new. Then Tesla has to recognize it as an EV charging site. And that's not straightforward, because sites are coming online all the time. And the way the Tesla algorithms work is that someone needs to charge at the site and have a good experience with it before Tesla wants to show it in their maps. So there's just a lot of things to get this right. And if you're on a Volkswagen or on a Kia, it's done a different way with a different map.
Are some of your work on the interface side of it that you can tell a car that I'm going to go to a supercharger, warm it up? Do you do that at the charger end or at the car end? Where is the interface?
So today it's on the car and power end, which needs to have that algorithm and figure out. But for them to know it's a charger side, the data needs to be available. So that's the side we can work on and make sure that they have all the data available, that this is the charging side and high voltage. And then I think the other side is on the EV charger side, at the point where the EV driver then starts the charger, they need to be informed about how this is probably going to work out. So in some cases, we have the telemetrics from the vehicles and we can do smarter things, but in other cases, we don't. And that's back again to this complicated ecosystem where the amount of data you have available to inform and educate is not the same from situation to situation.
Yeah, I'm just thinking loud. Someone must have set up a separate IoT device network that's universal to all chargers so that cars can directly tell, hey, I'm coming, no?
That's one way of doing it. Another way is they open up those APIs on the cars so you can activate that remotely. So you can do that on some cars with the telemetric, but again, that is also not one protocol. So each car manufacturer, each car brand have their own APIs. So you can imagine the amount of work that would be to add a feature like that.
This is something new I learned. But in terms of connectivity now, globally, the standard is CCS2, right? Because CHAdeMO and others slowly getting phased out, no?
So in US, it's CCS1, and then next, the Tesla standard, that is now becoming the standard here in US. And like CHAdeMO is on the way out in most places. So it's not even the same across the globe at this point. But Europe and China, CCS2.
This is interesting. What are the challenging projects you are working on right now within this ecosystem?
I think a lot of the work we're doing right now is on a couple of different sides, but I think one which really interests me a lot is on the energy management side. So what actually decides how you're allocating the aims between the chargers on the side? And by default in the industry, load management have been there and it's coming from other industries, so it's not really rocket science, but it's how you implement it and the inputs you have available to do smarter stuff. But if you think about it, so if you have, let's say, 10 chargers next to each other, the simple way is just to say, okay, we're going to split the aims, the kilowatts, equally across all of it. Then you figure out pretty quickly that's not super efficient because very rarely all 10 is charging at the same time. Okay, great. Let's make that more dynamic. Then the next step is you say, okay, let's detect where we're actually charging and then allocate only to them and then zero to everyone else. That's called dynamic. But then the next thing you're going to figure out is the charging curves are not going to be the same on the cars. You might actually have more aims available depending on the buildings next to your charging sites. How much are they using? Is it night where they don't have AC running and power on? Or is it during day where they might need a lot of it? And then everything becomes more dynamic, right? Then if you cross-reference that with a big last mile delivery site where you might have 200-300 cars coming in the afternoon, needs to be charged for tomorrow, then they have different capacity when they're coming in. Some of them only been driving a little bit, some of them have been driving a lot. The next day, they might have different routes as well, where some of them need a lot of battery, some of them need very little. They might start at different times. There might be drivers coming in from 5 o'clock in the morning to 9 o'clock. Some of them have 2 trips one day, and some only have 1. So when you start thinking about all those things together, it becomes a pretty complicated algorithm on how to decide who should get allocated what power at any time. And then the last part of the algorithm is you can take into account is on the grid side, is there actually something there we need to deal with as well? Now you saw the big power outage in Spain last week. Mm-hmm. Those things are definitely part of this industry as well, that we need to be aware when these things are about to happen and support, because we sit on a lot of that capacity needed to avoid these situations with using the charging and the batteries. So it's many layers of different parameters, and you need to prioritize and dynamically adjust to that real time. Makes it pretty complicated.
Yeah, if many cars are coming in and they are not using level 2 charger, so 22 kilowatt or something, they are no different from a bunch of air conditioners in a retail space, right? People can randomly switch on 3 kilowatt, right? Because if you are charging normal to 20 volts, that fluctuation gets lost into other appliances. But it is when all the cars start drying 22 kilowatt or even higher, right? That's when the situation that you're mentioning, optimization becomes super critical, right? Because you're talking megawatt of load shifting from one side to another, right?
Yes, I think the cars is definitely part of it, but I think the other part is like more renewable energy and more volatile power grids who have the flexibility to react really quickly when there's something. You don't want your house to shut off power while you're cooking, but maybe it's okay your car shuts off charging for a couple of minutes. So I think that is how we think about it. AC, it might also be okay to shut it down for a little bit of time, but it actually impacts you quite quickly. Maybe not as bad with AC, but it could also be heating, right? If you live in a part of the world where it's very cold, shutting off the heat for a little bit might be okay, but if you start shutting it off for hours, it could be life-threatening, right? So I think that's why the cars are just a very interesting asset here, that in most cases, they're connected to the grid for way more hours than they need to charge. And how can you leverage that capacity or flexibility, as we call it, so to stabilize the grid when there's events happening?
Yeah. So we are going towards the same point. I think the cars are more of a solution than a problem, because with V2G and V2L and all of those, it's a big battery sitting there. So they can actually smoothen the load profile of the system, because this is a big appliances that can be a generator instantly with a 50 kilowatt hour battery and maybe discharge at a very high rate as well.
100%. But even before you can discharge them, you can actually use this flexibility because you can stop charging.
Yep.
So at any point where there's thousands of cars charging and you stop that capacity back to the grid, even without decharging it. And I think that's the first thing we can do. And we already do that in a handful of countries. It's called the flexibility market, ancillary market. So pausing the charge within 5 seconds when there's a frequency reduction on the grid. That's part of it. But I think the other part of it is more on the demand response. So the utility knows, okay, tonight at 8 o'clock, I will have an issue on the power grid. So I might as well tell everyone to start offsetting charging away from that window. There's no reason that we're going to see an event happening on the grid before we react. It's a little bit more the proactive approach to it. That you can also do. And there's standards for that as well. And more utilities are asking for those kind of accesses.
Yeah, but that window can maybe quite narrow in a way, because as batteries approaches $50 a kilowatt hour, everyone will have a 100 kilowatt hour battery at home. I think every commercial block will have, I don't know, even few 100 kilowatt hour. Many places in Asia, they have a diesel genset as a backup because lifts and others. If everyone has a big kilowatt hours sitting in the home batteries space, and then of course you have the cars, tons and tons of cars with 100 kilowatt hour each. So I see that sort of maybe a more of a threat to the power companies, as opposed to them become a liability to the power companies. How do we manage this additional demand? Because right now we are going through a transition, so a lot of things going on. But in the longer term, when all our cars are electric or a large part of it, and then we have 100 kilowatt hours sitting there and a big battery at home, we care less.
100%. I think that's the decentralized way of the power grid will move into, right? That's coming. I think it's like, it's almost 5 years in this industry, right? And we had this as part of our initial plan when we started Monta, that we wanted to move to vehicles to grid and all that quicker. And I would say the industry is pretty far from that yet, and just have figured out how we can actually communicate and do that across, and getting chargers out, which can actually do vehicle to grid and do it efficiently. And so I don't think that's going to be the short-term solution, but I think the capacity markets with ancillary is definitely something we can do already, and we should implement already.
My house in Australia, I think I got a email from one of the power companies saying, if you give me access to your battery and give me the right to draw X number of times in a month, or total maximum this much in the year, I'll give you $500 cash upfront. So I do, okay, fine. So basically they will draw on the battery and this virtual power station, just pulling all the batteries together, right? So that was more than a year ago.
Yes, 100%. I think for most of doing these kind of programs right now is that very few have put into scale where it starts to work very well. So they need to incentivize you to sign up, because it's a little bit like a chicken and egg situation, right? You need enough capacity to make this relevant. And if you don't incentivize the asset owners to participate, why should you participate, right?
So your charging, then it's not quite charging. You are looking at a bidirectional, right?
100% is part of the thesis here. Right now, it's about doing charging very well because we want to make sure that we can support operators and EV drivers as much as possible over the next many years. But where this is heading long term is definitely seeing this as like one asset type and also thinking about other type of assets you have, like the solar panels, the batteries, the heating pumps, the ACs as well. But the EVs are just moving really quickly right now. So that's what we're focusing, especially Central Europe and North America.
How do you see battery swap fitting into all of those? I remember the company Better Place where Shai Agassi almost 15 years ago, maybe even earlier, that he had this battery swap out of Israel and Europe and was doing quite well and then just vanished. We also had Better Place in Australia, just vanished. But I see now in the smaller segment, the e-bike and electric three-wheeler segment, popularity on battery swap coming in. Do you see that as a threat, or how do you see that in the car industry?
I see it in the e-bikes and the scooters and all that. I think it's very smart because that also means you can bring your battery upstairs in your condo and charge at work, and you don't need big charging sites, and the battery swaps can be done really quickly. And the value of that battery is also a little bit less. I don't think it's fitting into the cars for several reasons. It's not as easy to swap. Like you can't just pull it out and pull it in like you can do with other ones. Secondly, it will just be a big part of the value of the car for a long time. So if you're swapping it with a less good battery, your car does perform worse. And can you sell at the same price when the charging becomes quicker and quicker? I don't think it's that important anymore to get that swap to work. That's why I think it's not going to happen. And I think we have seen good swings at it. Now you mentioned Better Place, but there's also been a few others. I think NIO is also doing it right now.
Yep, NIO, Xiaomi.
I wouldn't bet on that. I think it's fine that people are testing it out and we see innovation happening in all directions to push the limit where it can be pushed. It might eventually be used in some cases, but I don't think for every day is that meaningful. If you've been driving an EV, it's not that complicated to get it to run day to day. You don't need to charge that much as you think. If you have access to charging at home, it solves 95% of the problem. And that means when do you need to have a battery swap? That's when I do long distance. And right now with 400, 500, 600 kilometer ranges already, I think that is very fitting for when you need to stop anyway. And as we get to 200 kilowatt batteries over the next few years, that will be the double, right? And that means you can drive through half of Europe before you need to stop. And then you definitely need to stop. So take a break, otherwise it starts being dangerous, right? So I think for me, that is where it fits in. And then if you're twice a year when you are commuting far on a road trip, have to take a break or two more than you would in a diesel car, I think that's completely acceptable sacrifice for not having to visit petrol stations every 1, 2, 3 weeks.
It's a very interesting because that reminds me of like a first, when we had notebook computers, it was essential to have a spare battery, right? You will see everybody in the plane and everywhere, people just after a couple of hours shut down the computer, put a new battery in. Those things gone, vanish. How? Because the energy density gone up, right? Suddenly people need more break than the computers keep up.
For sure. And then I think you also got the power banks, right? So when I fly and travel, I still have a power bank and use that. But I think it's a backup, right? Just in case something happens. Today, like you're so dependent on your phone.
Absolutely. What I'm saying, the computer, we used to carry a spare battery because the energy density improve and a battery become lighter. So the computers now have a larger battery. So that industry gone. So same thing can be said about battery swap in a way, exactly as you mentioned, because it's a narrow window. As density goes up, people say, I'll get a bigger battery, 200 kilowatt hour. I don't need to deal with swaps and others.
Yeah, exactly. I think that's the tipping point in this industry. When we get closer to 200 kilowatt batteries, and we get the charging speeds and where we start seeing it now 5 to 10 minutes in the new ones. And at the same time, the pricing will be cheaper than petrol cars, then this will turn very quickly over and become the standard everywhere.
You know what? 200 kilowatt is a lot of electricity. That's what average household consumes in almost 2 weeks. In Asia, maybe a month. But an average Australian household, I think 15 kilowatt hour a day, 13 or 15. So if you have 200, that's almost 10 days worth of electricity, right?
Yeah.
including weekends when people are not at home. If you have a huge heating, like in very high up north in Europe, maybe little different, but still a lot of electricity, right? Can change the whole dynamics for the power companies. No?
I think for most, the 200 kilowatt is not necessary. I think what we have right now, 50 to 90, is more than you need for 99%. But I think it's that security around that you have the opportunity to go longer distance when you need. That is what holds the last cohorts back from making the change, that they're just so used to being able to drive 800, 900 in the diesel. So if you want to convince them, get close to that number, and at the same time do it at a price where it's not more expensive.
What about those? A lot of discussion about 5 years ago about induction charging. Highways will charge your car as you drive. Then the issues concern of EMR and others. Do you want to comment on that technology? Are you following that or not relevant anymore?
I saw a video this weekend about parking in China. Have you seen that with the robots, which can drive in under the cars and just move them around sideways and putting into every parking spot that way? I believe a lot in this, right? I tried to research a little bit on it and also buy some equipment and all that. No one really have it available in the market. It feels like it's still a lab project or it's installed one place. So I'm really looking forward to see when this gets a reality. I will definitely try to install it on my car as well and see if it can work. I think that would be great convenience. Even though it's pretty slow, like if it charges with 3-4 kilowatts, it's fine. But as long as it just charges whenever it's parked.
Yes, absolutely. I read somewhere, again, I have not checked, that Tesla Cybertruck has a built-in charger that other Teslas can charge. That's what I read somewhere, I'm not sure. But the reality could be, with a bit of electronics, a car should be able to charge another car, right? If you can create the voltage difference, no? If that becomes viable, like it's almost sharing, you've gone to a long drive and then your car ran out of petrol. We all have done that, siphon a few liters from another car and topping it up, right? Is that technology anywhere there? Any car companies doing that? Because the V2L they have, that won't charge another car. That's very low.
No, I don't think I've seen it. I think it makes sense until how do you settle that between the customers in terms of energy is worth something, right? Especially if you start pulling 10 kilowatts or 20 kilowatts. I'm not sure that is what the industry really needs to go in that direction. I think convenience and reliability is where I would go, and then make sure it's not so complicated. That just works the same way whenever you charge.
Yeah, because settlement will be quite easy. Most of Asia has that digital currency. People know kilowatt hour. You can just say, just tap phone to phone, it get paid. It won't be that someone running as a full-time retail business. It's just an emergencies and sharing, right?
Yeah, so for emergencies, sure. Like, then it also doesn't matter, right? You can settle on the side. But if it becomes more like, imagine you come into the mall and then you chain all the cars and there's just one charger on one side, right? And you just chain to the neighbor, then that kind of gets complicated, right?
Yeah, you can just say, I'm coming from a village. I've got 200 kilowatt of full charge. I need 10 kilowatt hour to go back wherever. Interesting world we live in. So what's your view? How much electric vehicle penetration do you see coming up in the next 5 years? 2030, many countries are banning the use of ICE cars. And I think those are still on the plate. The new ICE car will not be sold. Do you think that will happen faster than what was planned?
So for sure, if you look at Norway there, right, I think it was again 97, 98% last month. Then you have Denmark, you have Belgium now, which crossed 50% of the car sale. So I think the way we see it is like, when they get to 10 to 15%, it moves pretty quickly up the ramp to 20, 30, 50%. I think the only exception from that is Germany, Sweden, which had a bit of setback last year, where it moved quickly up and now a little bit back and now coming slower up. So I think for many countries, it will move very quickly. And as soon as it gets to a price point where this is meaningful, it will also move into like more South and Eastern Europe as well, and then it becomes mass adopted. We're starting to see second-hand cars really floating out in the markets now, especially the first generations of those, coming at a very reasonable pricing points, meaning that they can easily be absorbed by drivers who don't want to do the upfront investments and take the hit on the cost. But I think the cost point is really the driving factor. For many years, we thought about we needed more cars to the market. So you had all the different type of cars. There was SUV, sedan, all that. I think we're there now. You can get whatever car you want electric if you're at least open to look across a couple of brands. But if you want your Mercedes to be the same way as you always did, you still have to wait a bit. Not all brands made 7, 8 different models yet. The price point is what holds the mass adoption back. The countries where this really worked is because there's some incentive structure built in either on the car purchase or on the electricity afterwards. If you ask most of the population in Central Europe and North America, they're definitely considering an EV as their next purchase. And I think that's the important point for us to know this is happening. Yeah. So to summarize your question, I think it's going to go a lot quicker in some places, and then the average market probably fits that curve pretty well.
Yes, and I think also, although younger generation don't want to drive that much, but those who do, I see most people are looking at electric vehicles. Affordability is an issue, but there are a lot of cheap cars coming. Prices are going down really fast as the batteries have gone down.
Yeah, and then I think if you looked in Q4 last year, we were definitely under the thesis that all the legacy car OEMs, they were holding back on pushing this because they lost money on selling EV cars. They didn't manage to scale it in production to something where they could profit yet. And that means they would not push it further than the CO2 quotas they signed up for. And they're growing now, but also being held a little bit back. But now coming into Q1, seeing that Tesla is taking a big hit in a lot of markets, and the other car OEMs are now really increasing their market shares a lot quick, meaning it could be profitable before we know for some of those. And I think that is the tipping point for them to push harder in.
Yeah, and also Tesla, I just got myself a Tesla Model Y refresh, and it's an amazing car, what they have done. So I think if they come up with a cut down version, which we hear in the grapevine, that might happen as a cheaper version. And then everyone does it. So there will be a lot of choice. It's very difficult to buy a gasoline car then because it simply doesn't make sense.
Yeah, for sure. But I think for many, it was like, if you want to go electric, you had to really look at Tesla. Maybe in some markets, it was like BYD instead, but that was the front runners. And now you just see Volkswagen, Mercedes, and others and all those actually coming with really good EVs. And it's starting to be recognized. The market shares are growing quickly.
Yes, also there's so many no-name brand cars that are coming in from China. I mean, I've driven few. It's BYD, of course, is a very large company, very well established. NIO, a similarly listed company. Xiaomi, their brand is known. They make everything. But then there's so many Tom, Dick, Harris up there. There are a few hundreds, I think now, sort of consolidation, maybe 30. Still a lot of car companies, and they're selling.
Yeah, I was attending a few of the car expos around Europe the last couple of years, and definitely saw a lot of Chinese brands coming in I've never seen before.
Are we charging that is a global standard? You don't have a VHS beta issues or like a USB, like USB-C become a universal now, almost. So is the industry bodies globally working together to make sure everything is compatible? Talking to each other?
Yeah, yes, there's some standards which have been picked. So we're between the hardware and the server setups which are running on the backends, there's a protocol called OCPP. We have been, as an industry, stuck in a very old version for a long time, and we are hoping to see some adoption on the newer versions of the protocol. It's called 201. Right now, 1.6 is the mass adopted one. That is going very slow on updating because it's a much more complicated protocol. For a lot of hardware manufacturing, it's a big lift and the benefits are still limited. So we are standardized, but in a protocol from 2013 right now. It's a little bit old already. Then between the CPOs in the market, there's a protocol called OCPI. That is starting to be very well adopted now, meaning we can share data with each other, create these more seamless charging experiences. So if you are downloading app, for example, Monta, you can charge across all the networks in Europe and US. You don't need to go in and download new apps all the time, set up new payments. And I think that's also very important. Eventually, I believe that all of this should just be in the car. You set up your wallet with Volkswagen, whoever you want, and you settle with them once a month and they settle with everyone else and you just get your energy, get one invoice for that. That's a model we expect it to go on, especially as plug and charge, etc. gets rolled out better. So you just put your cable in the Tesla experience and it will just charge and settle that's also been much slower rollout than everyone hoped for.
Amazing, amazing. So what do you tell a wannabe entrepreneur who's studying or want to get into this space saying, I want to do what Casper is doing? What are the resources? What are the things people should do? Are there still opportunities in the charging space or it's already crowded? What do you think?
So definitely getting crowded, right? There's a lot of players in. Then we also start seeing the first generation changes on the first software companies, which came in early, not the ones really putting into scale right now. It requires a different skill set right now than it did 10 years back and 5 years back in terms of how you actually are scaling cloud software. I think there's plenty of opportunities to add value right now and figure out a way to do that. I think the problem is how the data is flowing and who is controlling it. And I think you need to analyze that a little bit before you go in and build a startup. I've seen tons of startups coming in right now. I actually just wrote about it, where I think they actually solve a nice problem, but they hadn't figured out how to really get access to the data to solve that problem. Meaning they're building something that's just AI. They're coming up with some predictive maintenance about when charging stations should be serviced. So the customer doesn't have to figure out this stuff is broken, it's figured out up front. But how do you want to get access to that data if they're not working directly with Monta or whoever sits on the back end? They don't get access to that data, then their business is just not like the work required to integrate with that business to get that value becomes much larger than just doing it yourself. And that kind of kills it for everyone to start working with them. So I think it's really study how those power dynamic works so you don't get blindsided in the industry. I would also recommend new generations of startups, don't think it as an incremental increase, really figure out how you can drastically improve something, even though it's a lot harder. I think we prefer to see more of that instead, because you need to figure out how you prove the industry that you want to look for and one which will stay. And this is the industry where a lot of money has been thrown at it early, but now everyone is trying to figure out how to actually profit from this. No one is really looking at just increasing their spend unless it really improves the value they're getting. What can the price point actually be? Can it be $10, $50, $100? When is this making sense for the CPO? And if you're adding another tool, it needs to kind of bring back its investments pretty quickly.
Yeah, but there is also another risk. I don't know whether you see that as a risk, because longer term, this business is a natural habitat for the power company. The utility knows everybody, our customers, everyone owns car. It's a natural extension, and they know on an average how many kilometers they're going to do. So it's almost like a health insurance, a lack of a better word, saying, okay, fixed fee. You charge wherever you want to charge. I'm the utility. I have 2 million customers. There are over and under recoveries, but a flat fee. Then I don't have to do all the metering costs, all this fancy hardware. I know where to bill. Ultimately, they have the natural sort of monopoly in a way if they want to come in, right? So that threat opportunity remains, no, for the power companies?
Yeah, so I think it's a common thesis in the industry to say, okay, the utilities have unfair advantage because if they make this work, they monetize on it twice, right? So compared to anyone else, that makes a lot of sense. And I think on the other side, you just see that the utilities are not known for being the innovators. So they need to let someone else go out and do this. And then when it gets very commoditized, they might go in and do it. So I think we believe a lot in the utilities. We believe that enabling a lot of the utilities is one of our biggest customer segments. And we're really tailoring a lot of stuff towards them. Most of them are very slow moving, not necessarily a threat right now. I also believe that the car OEMs really believe that they need kind of piece of the cake here, right? Because we know in their industry that pricing, there's a very big question on what is the initial price of a car used to be able to actually monetize that over 20 years afterwards in selling parts and services. And with EVs, that is also going to be less. A lot of the parts are very commoditized. They're not going to build a lot of the things, the batteries or the engines and all that. They're just going to buy the same parts, all of them. So a lot of them are trying to build services around the car, like with telemetrics or with charging, and figure out how to monetize another place. So you're going to see this kind of power dynamic play out between at least two, maybe more players, which feels they need to own this. And I think that always just makes room for smaller companies to come in and take the crumbs while they get the cake.
And then they get bought out.
Or the crumbs gets big enough for them to get some of the cake eventually. I think that's an option. But in some markets, utilities are super regulated, and that means they can't be first movers. They need to let someone else go in and do it first, and they can't really compete with local businesses. And then in other markets, it's unregulated and they're very commercial, and they are fighting each other as well. For example, what we're seeing in Denmark, that the utilities are taking a very active role right now in EV charging. They're using it to acquire customers. So when you change to an EV, you are going to increase your power consumption drastically. That's a good time to make sure you change to my power company, my utility. So I'm going to offer you a free home charger, but then you sign up for a power subscription with me afterwards. And I hopefully have you the next 5 years as a customer and can monetize on that. But they're also consolidating with telcos, with broadband, with insurance companies. They're becoming these like very large company groups.
Interesting. Thank you for sharing so many insights. Is there anything else you want to share?
No, I think it's been a good conversation. I've been around a lot of different topics. Appreciate that.
Yes, thank you. Do you see any big challenges coming up for the charging industry as a takeaway message, or do you see big opportunities? Where do you want to see charging in the next 5 years' time? What's your vision?
So I think my personal is that it gets so seamless that we can get everyone on board with it. You don't need to be trained to really understand it. That's number one here. And then I think the industry needs to figure out how to profit on this. Most of the companies are losing a lot of money on this right now. And what is the solution to that? Because the consumers are not willing to pay extra. So they need to figure out how to get this to work. So I think that is going to be the make or break it for a lot of companies the next 12, 18 months. Like they need to figure this out now. And that means we'll see big consolidation, both on hardware and CPO and software. That's what we are getting ready for.
Wonderful. Okay, that's good. So you see a lot of consolidation happening now as the cake gets bigger, where the big players will come in. Okay.
There's going to be many waves of consolidation. And I think the current wave we have right now is not the big players. The big players are still on the sideline looking at what happens. We thought they would be entering, but it looks like their strategy is to wait a little bit longer and see how this plays out. So the consolidation right now is going to be within the market, maybe some new players coming in through other markets and seeing this as an option and trying it out. But there's also a lot of established players which are exiting right now. It's getting super competitive. And I don't know how it is in Asia, but at least in Europe, it's extremely competitive at this point. US is clear, so now there's no consolidation yet. New companies coming in every day at this point.
Okay, tell me one thing. We expect a car, say Tesla, to charge at a 250 kilowatt supercharger. We read everywhere, and suddenly I appear and it gives me 60 kilowatt. What's done, Casper?
So the common thing is one of three. So either your battery is cold, so you just started the trip, or your car was not aware that you were about to charge. So you're coming in on a cold battery, coming in at a state of charge which is low, like 5%, 10%, and you don't see the peak at all. The other thing is you might be sharing energy with other charging cars at the site, either the neighbor car, that's the common one on Tesla, that if you charge at stall 3A and 3B, will share energy. But it can also be load managed across the site. So if there's a site with 20 chargers, then there's actually 16 cars charging. None of them are going to get 250. They're all going to get much lower. So that's the three common things we're seeing. And it's always a little bit of a gamble when you enter the site. What will happen?
So one should feel very lucky when you get a very high charge.
It's definitely like when I see 220, 230 on my Tesla, that's because everything is playing out. Like the moon is in the right position and the car came at the right time. I've only seen it very few times, especially in the US. Tesla charging sites are extremely utilized. You very often don't get full power.
Yeah, that's good. Thank you, Casper. Thank you so much. Let's keep in touch.
Yes, and thank you very much for having me. It was a good conversation.
Thank you. We hope you enjoyed this episode of Energypreneurs. To continue listening to this conversation, please visit us at Energypreneurs. Thank you. See you next time.